So good morning all. Welcome back to linked list chapter. Yesterday I had shared in the Google Classroom the programs related to singly linked list, and I had also told you to edit the same thing to modify it to doubly linked list. Okay. Other than those operations, I will be taking some other operations on doubly linked list now, and rest all I'll be giving as assignments to you. There will be a there will be a duration of 1 week. Okay, 1 week duration I'll be giving. Within that time you have to try doing all those programs and update the or upload the assignment on next Saturday. Okay, I'll be posting in the Google Classroom the assignment on linked list chapter. You are supposed to complete all those programs within 1 week of time and upload that by next Saturday. I'll be giving time till next Saturday 5 o'clock. Okay. Probably next Saturday you have your IA if I'm not wrong. Yeah, it is your internal 3 on next Saturday. So let's suppose I will give time up to 25th, that is on Friday. You're supposed to complete your assignment by next Friday before 5 o'clock. Okay, so make sure that you are practicing as much as possible because it's very important as far as third IA is concerned. Okay, so let's get started. Yesterday we have seen how doubly linked list is better than singly linked list and in what manner doubly linked list is having problems. Okay, we have discussed about that, and I had discussed only one operation on doubly linked list. Okay, that is of insert rare. Now I have already modified in the program to include insert at the front and display the details of the linked list. Those things are already done and I have already kept it ready. Today I'll be going ahead with one extra operation, something which I have not done as part of singly linked list. Okay, I'll be doing that and then we will be going ahead with the next things. So let me share the screen and we will go to the program. Okay. Um, is the screen visible? Is there any problem in the visibility? Please let me know. Is the program visible? Okay, visible. Thank you. And my audio is clear? Yes, thank you. Now, I have taken an instance of counting number of occurrences of a given element. And it means that user tries to search for an element. If found, it will count how many times that element has occurred. Okay, this is an application of searching. Okay, given a data store, in the whole of data store, you want to search for an element which is available. Okay, if present, at what point it is present, means the position at which it is present, and if present, how many times it has occurred. Okay, this is what is the problem that I am giving today. Now, in order to have the implementation done for this, I need to have already constructed data. Okay, already constructed data need to be done, need to be there. So in order to have that incorporation of already construction of the data, I have included insert rear and insert front as well as display function. Okay, suppose that the element that is given by the user is not available in the linked list. Okay, it is not available. At that point, it has to give a relevant error message. The element that you are searching for is not available. Okay, so we'll be continuing with this example today. Can I go ahead, guys? Are you all awake? Today it is 10:30 in the morning. Are you all awake? All active? Hope so. Yes. So I have modified the program like this. See, node of a doubly linked list. This we have discussed yesterday only. I have done the same thing. And then the create node function, I have kept it as it is. Type def struct node star capital node. Okay. Then create node, I have kept it as it is. I have not modified. Yesterday we have discussed about it. Please note it. Okay. And insert rare, I have already discussed in yesterday's class. The same thing I have incorporated. Please have a look at it. The same thing, no change at all. Okay. And I have added one extra function, which is insert front. Okay. Now, in the insert front, we will just have a glance of it and then go ahead. Okay. Say, let's suppose I will just go to the end of this. Okay. Let's suppose I have the element insertion like this. You have to give me 1 minute of time. I'm so sorry for it. I would have created it early. Okay. So this is one such table which I have created. Okay. Now what I will do, okay, 1 minute. Yes. Let's suppose I have the elements like this. Okay. There is an element 10. There is an element 20. There is an element 30. Let's suppose like this. Now I want to insert an element at the front of the list. Okay. I want to insert the element at the front of the list. Now how I am supposed to do this? See, I want to insert an element, say 5 before 10. How can I do this now? This is pointed by temp. 5 is pointed by temp. Okay. Temp arrow left is null. Temp arrow right is null. All right with this. Now if I want to add this 5 before 10, how can I do that? Temp arrow right is equal to first arrow left is equal to temp. All of you are right. So the same thing has been done in this. See guys, you have got the grip of this now. That's why you are answering so quickly. Okay. So let me just go ahead and show you. Temp arrow right is equal to first. And what is that I need to do? I need to do this. First arrow left is equal to temp. Correct? So this is what is required in creating or in inserting a new node at the front end of the list. Okay, shall we go ahead? Next, I have doubly linked list display. Okay, I have to have a display of doubly linked list. So what is that I need to do? I need to address each and every node. Okay, each and every node until current reaches null. See, I think Anushka had asked me this question yesterday about when to write current arrow link not equal to null, when to write current not equal to null. Okay, this is a point where we require current to cross the last node also. Okay, because I have to address the last node and the loop continues only when current becomes null. Current is pointing to nowhere, only then it has to stop. This is where I use current not equal to null. Okay, now I have added current is equal to first if it is equal to null, empty list and return. Current not equal to null until current not equal to null. Print every time current arrow info and try incrementing current. How do I do the increment of current? Move from current to current arrow right. Okay, this continues until the end of the loop. So this is display function. Now what I have done, I have taken 5 choices. One is insert rare, second is insert front, third is display, fourth count occurrences of an element, and fifth is exit. So I have already edited case 1, case 2, case 3 and case 5. Okay, I have kept blank for case 4. All right. So when I want to print the count of occurrence of a given element, what all are the parameters that I may require? Can you have a guesswork for this? So let me give the name as count occurrences in doubly linked list. Okay, this is the name of the function. What all are the parameters that I may require? Any comments from your end? Okay, I will require the key element, then count and first key and array to store the positions. Okay, um, so let me check out like this. What is that? Let me declare a variable which is called as key element to be searched. Okay, so what I will do is I will pass this key definitely. Okay, so what is that? I will just tell printf enter key to be searched, similar to binary search or linear search program. Okay, then scanf %d ampersand key. All fine. Next, what I need to supply this key to the count occurrences. Okay, so I'll pass first. Why do I require first? Because I need to start searching from the first ever element. Okay, then I would require a key. And Praveen has commented one thing. You may require an array to store the position at which the key is found. Okay, see, this is optional. Suppose that some other function is in requirement of the positions, only then you need to store them. Here the requirement is I will just search for it. If found, I will print then and there only where the key has been found. Okay, so let me just go ahead with these two parameters right now. Okay, and I will create a function for it. So let me just make use of this header function header function heading. Okay, and the name of the function is count underscore occurrences underscore DLL. What all are the return type? I have kept right now as void. Parameters, I require address of first node, then key to be searched. Okay, then it is used for displaying position at which key is found and also find count of occurrence of the key. Okay, now with this background, let me just begin with writing this function. Okay, void, I may call upon any one of you to tell me what should I write here. Okay, void count underscore occurrences underscore DLL of node first. Why first? First is required to have the searching beginning at the first element. Okay, int key. Let me take the same variable, doesn't matter. Right now I have only two parameters here. Okay, now what is that I need to do? Can anybody suggest me what should I write at this point in time? Quickly. Okay, definitely I will go like this. If first equal to null, first of all I have to cover up the base condition. Okay, if first is equal to null, I will write printf the list is empty, cannot search %d in the doubly linked list. Okay, %d is, can anybody tell me what is %d? Yes, it is key, correct. Then I will simply write return. Okay, simple return can be written even if you don't have any return type. I have been repeating this so many times. Okay, if it is not the case, then what should I do? Every time, can you move first? Definitely not. Okay, so what I will do is, as usual, I will restore first into the current. First into the current. Okay, current is equal to first. Then, while current not equal to null. Why it is current not equal to null? It is just because I have to consider even the last node. I should not stop at last node. I have to include the last node. If I want to do the following operation excluding the last node, then I will write current arrow link not equal to null. But here, when I am counting the number of occurrences of the given element may be available at the last node also. Okay, so I have to include the last node also for considering this kind of searching. That's why I have written current not equal to null. Then what else? How do I write the position? Okay, let me just go through the comment that is given by Anushka. If current arrow info equal to k, then count plus plus. Then write current is equal to current arrow right. Okay, what she has done, she has called if current is equal to, inside this while loop it is. Okay, if at any point in time current arrow info equal to the key to be searched. Okay, so what is that I'm doing? Count is equal to count plus plus. Sorry, count is equal to count plus 1. What is this count? Have I declared it? I'm not declared it. So what I will do? I'll write the declaration of local variable which is called as counter. Okay, count equal to 0 I have assigned. Okay, then I also require what is called as position. What is this position dealing with? It is trying to dealing with the first ever position. If I have found at what position the element is found, that needs to be printed. For that reason I require one more variable which is starting from first position. Okay, now so what I'll do, count plus plus I'll do, and then I'll write printf %d is found at position equal to %d. Okay, comma. First %d is the key element to be searched. Second %d is the position. Then every time after I have printed this, current will be incremented to the next node. So how can I do the increment of current? Current is equal to current arrow right. Then along with that, I will do position plus plus. Because when I increment current, right now the position of the current is the next node. It is plus 1 of the previous value. Okay. Now at the end of this while loop, I would have got the total number of occurrences of the key node. Okay. Now tell me at what point you can infer that the element to be searched is not found? At what point? Or how do you infer? This whole thing is written assuming that already the element is present. Position is incremented only if, no, only if key is found, position is incremented. Yes, you are right. So where should I place this pose plus plus? Should I keep it outside the for loop? Outside the if? Definitely it is. Be it anything, whether found or not found, I have to increment the position. You are all right. 100% correct it is. Very good. Then Mm, okay, what about current is equal to current arrow right? Should I keep it as part of if or should I keep it outside? If I keep it inside, only when I have found the element, it will be incremented. Okay, so all of you are right. And I'm really proud of you. Okay, you are finding the problems that I've created in the function on your own. Okay, it's very good. You have got a very good grip of the programming. That's why you can tell it. Otherwise, you cannot tell it. Okay. Tell me where it is exactly you are trying to tell key not found. Is there anyone who can unmute and tell me? Okay, how do you tell that key is not at all found? How do you tell? Key is not at all found. Which which variable decides that key has not been found? All of you are right. So nice of you guys. Okay, if I will tell after the while loop, if count is still a zero, okay, still a zero, and you have reached the dead end of the linked list, so both must be true. If count is 0 and current is pointing to null, at that point I will tell that key to be searched is not found. Okay, so if this is the case, what I will do? I'll write printf %d is not found in the list. Okay, now at the end of this if, definitely it will return back. I need not write it explicitly. Okay, so otherwise printf total number of occurrences of %d is equal to %d. Okay, let me just write %d is key comma count. Okay, now I'll just go back to main. Have I done all the things properly? Yes, I have done it. So let's check this. Okay, guys, this is the program. This is the function created by you. Whatever you have told, I have edited that. Okay. So cross your fingers and let's say this works fine. Okay, let me insert few elements. Say 1. At rear end, I will insert 10. 1 again, I'll insert 20. Sorry, I'll exit and restart it. I have entered wrong option. Okay, let me insert 10. Let me insert again, say 20. Okay, let me insert again, say 10 again, insert again, 20 again. Choices to insert from the front. I will insert 30. Okay, and let me display it. So I have the elements like this: 30, 10, 20, 10, 20. Okay, now I just want to find the number of occurrences of the element 10 and at what position the element is found. Okay, you just have a look at it. 10 is found at position 2, 10 is found at position 4. Total number of occurrences of 10 is 2. It is 100% working now. Okay, now I just want to have a bit of modification to this. What is that bit of modification I wanted? Please guys pay attention and put a bit of stress on your brain for this question that I'm asking. Okay, now it is found that you are finding the number of occurrences for one particular element. Okay, one particular element. Can you do the same thing for every element that is available in the linked list? I'll repeat. If I have in the linked list 10, 20, 10, 30, 20, 40. Please write it down, all of you. 10, 20, 10, 30, 20, 40. I hope all of you have taken down 10, 20, 10, 30, 20, 40. This is what is the elements available. For every element that is available in the linked list, for every element, you have to print the number of occurrences of that particular element. Can you do the modification for this? It means I am not giving any key element here. I am not giving any kind of key element here. So how much time you require for thinking about this? I want only the idea how you can modify this program. Okay. Uh, I do not have any key option here.
Ma'am,
Every element that is encountered, that becomes a key. Yes, may I know who is speaking?
I'm Yogesh.
Yes, go ahead.
Ma'am, in this, first of all, we'll take 10 and we'll compare to the whole list.
Hmm?
If 10 is found, then what is the location? And then next to 20,
Hmm?
we'll compare to the rest list again. And if
Hmm?
again it is found, then list the number and we'll do it till the last, till null. And two loops will be required.
Okay. Can you try this out for today, Yogesh?
Yes, ma'am.
The way you have told, it is 100% correct. This is how you have to go ahead. Okay. Guys, tomorrow morning 9 o'clock class when I start, we will be beginning with this example discussion, and for tomorrow's class, it is not Indira madam's class, it is students class. Okay, so you will be presenting, you can make out from your end, okay, who will be presenting tomorrow. By tomorrow, you should be ready with this program. Okay, if you want me to share this program to you, I will definitely share it immediately after the class. Okay, but make sure that you are ready with this program and you are taking the class tomorrow. If you don't take class tomorrow, no class will be there. Am I clear? No one is speaking.
Yes, ma'am.
Yes, you will do that. Okay, then tomorrow it is third B class. It is not Indira madam's class. Okay, so you take a call. Who will be presenting? You take a call. I will not be assigning anything. Okay, you take a call from your end, and please send me a message in my personal WhatsApp who will be presenting tomorrow. Okay, it's your call totally. You, Anushka and Aryan, please let me know. Okay, after discussing among yourselves, please let me know about it. Yes, so I'm just eagerly waiting for tomorrow's class. Yes, then we'll take one more function. Okay, today we will take one more function. Um, say, let's suppose in the given linked list, if an element is found, that element, is it an even number? If it is an even number, add 1 to it and make it an odd number. Okay, I'll repeat. While searching through, or while going through the whole linked list, if I find an even number, if that even number need to be modified into an odd number. How? By adding 1 to it. If I find an odd number, subtract 1 from it and make it an even number, 1 before the odd number. Okay, I will repeat again. You have to go through each and every individual node of the list. Okay, and if you find at any point in time an even number, convert that into next immediate odd number. How do you do that? By adding 1. Okay, and otherwise if you find an odd number, convert that into a predecessor even number. How do you do that? By subtracting -1. Okay, so I'm talking about odd numbers predecessor, even numbers successor. This is how the problem statement goes. Convert even number into its successor odd number. Convert odd number into its predecessor even number. So it means +1 -1 you have to do. Yes, can you quickly do this? I'll stop sharing and I will also do it parallel. How much time you require for this? Hardly 2 minutes. Anyone completed? If completed, tell yes. Type yes. Yes, anyone completed? Okay. Okay. Okay, good try. So let me share the screen for you for the solution. So is it the same thing that you have done? Okay, well done. So we'll take up one more. In next 5 minutes, you have to complete it as quickly as possible. Okay. Um, create a function for searching an element. If found, delete that element. Search an element. If found, delete that element. Current equal to current arrow, right? You're right. Oh my God, you have become the teachers of mine. I'm very happy for it. You are 100% correct. Good going. Keep it up. See, at any point in time, if a student crosses a teacher, that will be the happiest moment for the teacher. Okay. And you are achieving that. I'm so happy for it. Now, I'll repeat the question. Mm, you have to search for an element, given key element. If found, delete that element. It may be n number of occurrences of that element. So how should I modify? the count number of occurrences that we have done. I'll just copy this. I'll copy the whole function. I'll do the modification as and when required. Okay. So let me just paste it. And instead of count occurrences, delete key. I require a first and I require key. Okay. Then I do not require this count, obviously, because I'm nowhere counting the number of occurrences. Then current is equal to first, current not equal to null. If at any point in time current arrow info is equal to key, instead of incrementing count, I should do something. What is that? Let me take obviously here previous is equal to null. Okay. Yes, can you help me out in building this function? Praveen has written me the whole code. Let me just read it. If it is correct, we will take it. Others can try this, please. Don't look at the chat. Praveen, where are you linking previous node to the next node after deleting temp? You have to link the
Sorry.
previous node. Yes, you have to link. That is missing.
After that, opening of the while, I will add it.
Yeah. You have to add that. Yeah.
Sorry, ma'am.
Yes. Good try.
Thank you,
Yes,
ma'am.
anyone else? Tell me, are you finding it interesting? Yes, obviously. See, this should have been a physical class. I think I have told it so many times about it. We would have mocked this. Okay. Usually I teach linked list in the class by creating a mock. Okay. It means I make 10 students to stand on the stage and show all the operations among them. This is how I teach this chapter. Okay. That is missing in the current sessions. That's missing really. Can we do that in February? Definitely we will do that, Yogesh. I would like to mock all the data structures, okay, in the class. When you come over here, we will do that definitely. By that time, the whole of the portion will be over. So it is just a repetition of the things, okay? So I'll be more than happy to take classes at that time. Definitely we will do that. Okay, any other solution for this? What should I write here? What you tell, I will type. Okay, I'll write previous arrow right is equal to current arrow right. So if this is the case, what I will do, let me write this previous arrow right, but where will be previous and where will be current? Every time I should do this. Okay, previous is equal to current. Now, if at any point in time, key has been equated to current arrow info, then I'll write previous arrow right is equal to current arrow right. Who is this current arrow right? The next node. You just have to imagine like this. Previous is on the first node, current is on the second node, and current arrow right is the third node. So I'm linking right of previous to the third node. So afterwards, I need to link back current's right to the previous. How can I do that? Look at the way I'm writing it. Please pay attention for this. Okay. Current arrow right What this gives me? Current arrow right will give me the third node. It's a left. You can very well write like this. You can very well write like this. Okay. Current arrow right, its left is equal to previous. Guys, you just have to have an imagination for this. I will go back to this. Okay. I will delete this for a while. Now you just imagine there is previous here, there is current here, this is current's right. Okay, so what is that I need to do? I need to delete this node by doing what? By doing 10's right to be pointing to 30. How? How can I reach 30? Current arrow right is 30. Okay, current arrow right is 30. So previous arrow right is equal to current arrow right. So previous arrow right 10 gets pointed to 30. Okay, now the left part of 30 should point back to 10. Okay, should point back to 10. How can I get the address of 30? I can get the address of 30 by doing current arrow right. So current arrow right's left. Left, I need to connect to previous. This is what I have done. Are you able to analyze this? I hope so. Please type yes if you have understood this. Okay, in the same manner, I have connected previous and current's right. Now what I need to do? I need to simply write free of current. But my question is now, will it work for all the nodes? When I'm trying to delete a node, always pay attention. When you are trying to delete a node, you should think it very carefully. You should take the different occurrences separately here. Imagine if the node to be deleted, the key to be searched is found at the first position only. Can you apply this at that time? Can you apply this at that time? Previous arrow right is equal to current arrow right. So first node will be pointed by current. Okay. Previous is pointed by null. Okay. Now current arrow right is your second node. Current arrow right is second node. Let me just take this example itself. 10 is the element to be searched. So 10 needs to be deleted. So where previous will be pointing? Previous will be pointing to null. Okay. And when I enter the loop, previous is pointing to current. Okay. So how can I solve this problem? What is the way out? What is the way out? I should take the first ever node separately. Then otherwise everything else will work fine. Okay. So current not equal to null, I should take it only when I have more than one element and only when I have the key to be searched is not a first node. Okay, so you have to consider that condition separately. How can I check that? If first arrow info equal to key. This is a condition, and at this point I am moving the first itself to the next node. Are you getting this? Are you getting this? This is where search and delete is different. Guys, for tomorrow's class, you have two assignments. This function you have to complete totally, and the other function that I have told you, the two functions you have to show me the solution from your end. Okay, from your end you have to show me the solution, and please make sure that you decide among yourselves who will be presenting tomorrow. Shall I take a yes from your end so that we will end the session for today? I'm left out with only 2 minutes. Okay, so I hope that from the 2 CRs I will get the notification for tomorrow's class who will be handling. Okay with that? It may be written stuff, it may be typed one. Whichever it is okay for me. Okay, I'm not restricting you to have a written stuff. Okay, guys, have a nice time. Enjoy. Thank you. Now there is DMS class. Please join for the class. Thank you all.
Thank you, ma'am.
Okay, see you tomorrow.